All right, 9.4 rational exponents. Unit 6 is what we're in. So rational exponents, to begin with. You can simplify a number with a rational exponent by converting the expression to a radical expression. So for example, if I have x to the 1n, that n represents the, excuse me, the index of my radical. So the n is the index of my radical. Notice it's 1 over n. So the n is the index of the radical. So here I have, for our first little mini example, 9 to the 1/2 means that it's 9 with an index of 2. So I'm looking for the square root of 9, which is 3. Here I have 8 to the 1/3. Again, my denominator is a 3. That means it's an index of 3 on my radical. So I'm looking for the cube root of 8, which equals 2. Okay? To make this a better answer, plus or minus 3. All right. Exponent rule that you need to remember is that when you are multiplying two expressions with the same base, what you're doing with your exponents are adding them. So it's the sum of the powers. Do we remember this rule? Yeah? Okay, good. So recall that. When it says to put something in its simplest form, you want to simplify all exponents and write every exponent as a positive number using the following rules. So if I have a to the negative n, that means, remember, that means that my expression actually belongs in the denominator, okay? And then vice versa. If I have a negative in the denominator, that means it belongs in the numerator, okay? Our product rule here, our power rule. So our power rule, if I have a power times a power, that literally means I am multiplying them. Okay, and then power rule part 2 is that if there is a power and there are two things being multiplied, you have to distribute that power to both things. Do all of these exponent rules ring some bells? A little bit. You got to pull out. So here we have 36 to the 1/4 times 36 to the 1/4. So notice that my bases are the same, right? So this can equal, using my product rule, that means that I have 36 to the 1/4 plus 1/4 power, which equals 36 to the 2/4, which equals 36 to the 1/2. So we use our product rule here for exponents. Now that I think about it, I think I accidentally posted the exponent rules to yesterday's notes, didn't I? I did, didn't I? I just thought about that. I meant to post it on today's notes in your Canvas. Yeah, my bad. No. The video's right. I'm saying on the, when you go to your notes page, you should have all those exponent rules you need to recall. And I should have posted it on today's notes page. My bad. All right. So now I have 36 to the 1/2. Well, using our rational exponent rule. So using our rational exponent rule, what does this half mean I'm actually doing? That means that I'm actually taking the square root. It means that my index is 2, and I'm looking for the square root of 36. So 36 to the 1/2 is the same thing as me saying, what's the square root of 36? And what's the square root of 36? Plus or minus 6, right? Was it terrible? All right, let's try another one. So we're going to simplify. So first, focusing on numbers, we're going to combine like terms through commutative and associative properties of multiplication. So we have 6 times 2, and we have x to the 2/3 times x to the 3/4. Well, 6 times 2 is easy, right? Basic multiplication. X to the 2/3 and x to the 3/4, that's using my product rule of exponents. And that means that I'm actually adding 2/3 and 3/4 together. Okay, so let's talk about adding fractions really quick. Recall that in order to add fractions, they have to have the same denominator, but we can do a little shortcut, especially when we see things like 3 and 4. Pretty simple denominators. But if you remember you can cross multiply. I call this chopsticks in a bowl. My high school teacher called it bats and ball, which made no sense to me. But I call it the chopsticks in the bowl. So my first chopstick, 2 times 4 is 8. My rice in my bowl, in order to eat my rice, I need my second chopstick. 3 times 3 is 9, and it's all in a bowl. 3 times 4 is 12. And this gives me 17/12. Now, doesn't chopsticks in a bowl make more sense than bats and ball? Her son played baseball. She always tried to talk about him in class. You see chopsticks in a bowl. We both know you do. All right, how do we feel? Still easy? That is 17 and 12. Do they have a GCF? And that's the smallest it can be. All right, next, we're going to talk about the power rule of exponents. The power rule is saying that I'm going to distribute this to everything on the inside. So I have to distribute to the 8, distribute to x to the 9, and distribute to y to the -3. I also have my negative rule. And my negative rule tells me that where does this y actually belong? In the denominator. Good job. So I have 8. Well, we'll see. -2/3. And then I have x, 9 times -2/3. -2/3. And then a y, -3 times -2/3. I'm going to simplify my exponents. So 8 to the -2/3. So with 8 to the -2/3, it brings us up with, now instead of just having a 1 in the numerator, I actually have a 2 in the numerator. Do we see that? Also, it's negative. So because this 8 to the -2/3 is negative, it actually belongs in the denominator. So it becomes 8 to the +2/3. Here, I have 9 times -2 to the 3rd. What is 9 times -2? -18, right? And -18 divided by 3 is -6. Notice how I'm saying -6. So if this is x to the -6, it actually belongs in the denominator. So it becomes x to the +6. Here we have -3 times -2. What is -3 times -2? 6 is a +6. And what is 6 divided by 3? And so this one actually stays in the numerator, because it actually turned out to be the only positive power. Now let's talk about 2/3. What we have here is we have 8 to the 2/3. And what this is, a key thing to remember is when you have a fraction as an exponent, it's your power over your, instead of saying index, just so you can remember alphabetically, I call it the power over the root. Okay, so what this means is that if I have this as a power, I don't know why I wrote it so big, it's going to become my root, my power. Okay, let's talk about that again. So if I have an exponent and it has a numerator greater than 1, and then I have my denominator, it can be rewritten as my root and my power. It can also be rewritten as I take the root and then I take the power. So there are two ways for this to be working. So for our 8 to the 2/3, the question is, would I rather go big first or go small first? I personally prefer to go small and then go big. So I can take the root, which is the denominator of 8, and then I'm going to put it to the power, which is 2. What is the cube root of 8? What number times itself 3 times produces 8? 2. And what is 2 squared? So 8 to the 2/3 equals 4. Okay. What do you mean? Let's try it again. We'll do it again. So we have y squared, 4x to the 6 is my simplified and final answer. So we had to use several rules here. We had to use our power rule. After we used our power rule, we then used our product rule. Not product. We used our power rule, and we used our negative exponent rule. And then we were introduced to our exponent rule, our rational exponent rule.
So in the denominator, that 8 is under the root.
Mm-hmm.
And you took the numerator, you put the outside.
As the power.
Okay.
Mm-hmm.
And the 3 fell
to the root, the radical.
Okay.
Mm-hmm.
Okay, never mind.
All right, so we're gonna simplify each expression, assume that all variables are positive. So just a really quick check that you understood the basics of it. So for number 1, we have 5 to the 1/3 and 5 to the 2/3. What will we do? Which rule are we using here? Power, product, negative, rational exponent. What are we doing here? Product, perfect. So we're using the product rule. Product tells us same base, means that we're going to add the exponents together. And 1/3 plus 2/3 equals 1. So the answer is just 5. All right, number 2, we're still using what? Still using product. So we have 2 times 3, and we have y to the 1/4 plus 1/3. So what do we say for 1/4 and 1/3? So we have 1/4 plus 1/3, cross multiply. 1 times 3 is 3, plus 4 times 1 is 4, all over 4 times 3, which is 12. What do we get? 7/12. 6y to the 7/12. Do you think product rule changes just because there's 3 of them? No, it does not. It still means I'm just going to add them all 3 together. Does that make sense?
How would you do the cross multiply that?
Would I need to?
Probably not.
Are my denominators different? So is there a need to cross multiply? So we have negative 11 to the 1/3 plus 1/3 plus 1/3. What does that equal? 1. So the answer is just simply negative 11. All right. Are we comfortable with the various forms of the product rule? All right. So just to make sure you are, I would like for you to take a moment, do these 3 on your own. All right, so let's talk about number 4. So number 4, notice there's a negative. That's just saying like there's a negative 1 there, okay? So here we have y to the 2/3 times y to the 1/5. Again, product tells me that I'm going to add 2/3 plus 1/5. And 2/3 and 1/5, whether you do common denominator or the chopsticks and bowl method or scenario that we kind of talked about, you should have ended up with 13/15. So we have negative y 13/15. Good. All right, here we have 5 to the 1/4 times 5 to the 1/4. So that means that we have 5 to the 1/4 plus 5 to the, plus 1/4. And that gives us 5 to the 2/4. And that simplifies down to 5 to the half. If it does not ask for the radical of it, then you leave it as 5 to the half. Okay. The reason why I say if it doesn't ask you, the radical of this would just be the square root of 5. These are equivalent statements. All right, on 6. So we have negative 3 times 7. And we have x to the 1/6 plus 2/6. Gives us negative 21 times x to the 3/6, which gives us negative 21 x to the 1/2. Easy enough? All right, let's get a little harder. All right, so we have 16x squared, y to the 8th to the 1/2 power. So using our power rule, we have to do what? Distribute this power. You get a half, you get a half, you get a half. We all get a half. So we have 16 to the half. We have x to the half, x squared times 1/2. And then we have y to the 8 times 1/2. 16 to the half. What does the half mean I'm doing with 16? Yes, x squared times 1/2. It means I'm taking the square root of 16, right? And then here, 2 times 1/2 is just 1, agreed? And 8 times 1/2 is 4. So that means my answer is 4xy to the 4.
So 16 isn't affected by the half.
It is. The half means that you're taking the square root of 16. All right, let's look at 8. I'm going to do power rule again. So I have z to the negative 3 times 1/9 gives me z to the negative 3/9, which simplifies down to z to the negative 1/3. What does the negative 1/3 tells me about this z? It tells me that it actually belongs in the denominator. All right. 9, we have 2x to the 1 4 to the 4th power. Distribute, distribute. That gives us 2 to the 4 times x to the 1 4 times 4. What is 2 to the 4th power? 2 times 2 times 2 times 2 is 16. What is 1/4 times 4? It's 1. 1/4 times 4 is 4 over 4, right? And what's 4 divided by 4? 1. So my answer is 16x.
Well, number 2, is that 1 over z 1/3?
Yes. It's a fraction. All right. So,
Why do you have 2 fractions and 1 dollar?
I have 1 over z to the 1/3. The 1/3 is the power. All right. Let's get a little extra. So we start off easy. So here we have 25x to the negative 6 power, y squared to the 1/2. So I'm going to distribute, distribute, distribute. So 25 to the 1/2 times x to the negative 6 times 1/2 times y to the 2 times 1/2. What does it mean when I'm taking the half of something, half power? It means you're taking the square root of it, okay? So again, remember, the numerator is the power, the denominator is the root. I have negative 6 times 1/2. What is negative 6 divided by 2? Negative 3. I have y to the 2 times 1/2. What's 2 divided by 2? 1. So I keep simplifying this. The square root of 25 is going to give me 5. And my x to the negative 3 belongs in the denominator.
It goes in the denominator because it's a negative.
Because the power is negative. Okay. So we have 8, a to the negative 3rd, b to the 9, 2 to the 3rd. So we're going to distribute, 8 to the 2/3, a to the negative 3 times 2/3, and b to the 9 times 2/3. 8 to the 2/3 means that I am taking the cube root of 8 and then I am squaring it. Do we see that? The cube root, so the denominator is my root, the numerator is my power. So this becomes cube root of 8, and then I'm going to square it. Then I have negative 3 times 2 is negative 6. Negative 6 divided by 3 is negative 2. I have 9 times 2 is 18. 18 divided by 3 is 6. So I keep simplifying all of this. What is the cube root of 8? And 2 squared is? So we have 4b to the 6 in the numerator and a squared in the denominator. Why is a squared in the denominator? It has a negative power. All right, let's try with a full-on fraction to begin with, rational to begin with. So we have negative 1/2. Because it's a fraction, it goes to every value in the numerator and denominator. So this is going to become 16 to the negative 1/2, z to the 4th times negative 1/2 over 25 to the negative 1/2 times x to the 8 times -1/2. Okay, so again, notice how I have negatives in the numerator and negatives in the denominator. Because they are negatives, that means that these values are switching. A negative in the denominator means it belongs in the numerator, and a negative in the numerator means it belongs in the denominator. So here, when I'm taking the 16 to the -1/2 power, that means I'm going to have a 4 in the denominator. Because that half power means I'm asking myself, what is the square root of 16? So this became that. Okay? So we have 4 times -1/2 gives us -2, -4/2, which is -2. Because it's a -2, that means that it's going to be in the denominator. Now I'm going to do my denominator here, which is going to be my new numerator here. What does the half power mean I'm doing again? Square root. So the square root of 25 is 5. 8 times -1/2 is 4. So I have x to the 4 in the numerator. Do we see why and how the numerator and denominator switched roles? All right, number 13, you're gonna have to write in because it's not on there. What if you start off as a radical? You're gonna go backwards. You're gonna convert the radicals into a fraction. So if my radical is the cube root of x to the 4, then this means that I have x to the 4 to the 1/3. Do we see that? Here, I have 6. If there's no index here, what does it mean the index is? Means it's a 2. If there's nothing there, that means the index is a 2. So this becomes x to the 4 to the 1/2. If multiplication means I am adding, what does division mean I'm doing between my powers? Subtracting. So 1/6 has nothing to do with that, right? But when you are dividing, that means you are subtracting the powers. So I have x to the 4 4/3 in the numerator over x to the 2 in the denominator, which equals, again, 1/6 is its own thing. And that gives me 4/3 minus 2. How do I find the difference of 4/3 minus 2? Yeah. Turn 2 into a fraction and either cross or find common denominator, right? So we have 4 times 1 is 4 minus 3 times 2, which is 6, times 3 times 1, which is 3. What is 4 minus 6? -2. So I end up with 1, 6, x to the negative 2/3. What does that negative 2/3 means about this x? It belongs where? In the denominator. So my final answer is 1, 6, x to the 2/3. Okay. Well, let me know where I can help.